Welcome friends. Today it is very important lecture, and this is very important for the placement as well as for your subject. Okay, we will discuss the BST binary search tree and AVL and AVL tree and RBT. Already we discussed last time. Again we will discuss how to delete in RBT, how to delete in B tree and also in heap. And before starting the lecture, again, I will remember uh, already we have written all the codes in Colab. You can check. Okay, all the classes we have written in a very good form, and you can check. There are total number of 14 programs, but 20 programs, but we have written total 35 programs in advanced data structure. Whatever we taught inside the class, we have explained here step by step. So you can check, and also we explain inside the classroom. So you people, you should go here and check the link. All the links are free of cost. Okay, there is no need. Okay, we explain everything step by step, whatever we taught inside the class. Same thing also for discrete mathematics, we explain all the codes because that is the logical, and we are working in artificial intelligence, so it is very important to write the code in every subject. We have written such type of code in every subject. If you open whatever we taught inside the classroom, we have written in a very good method. Okay, same thing also for other. If you'll go other data visualization for every, there are many codes available in Colab. Okay, we have written the codes for every subject. And similarly, last time also we discussed about the my research, and this time internet is not working. You can check. We will come here. We will start first BST. So this is very important topic. Why this is very important topic? Because if you want to know how to delete in BST, if you learn only BST, then you can easily understand AVL as well as RBT as well as B tree. Okay, so everything you can easily understand only BST. And in BST, this is the main topic. This is the main topic. Actually, what is going on? Rotation. Now you can see what is this. This is the left and this is right. Okay, this is left and this is right. So if you want to rotate, then how to rotate? At first you can see this is LR. Okay, this is LR, means left, right. I will make symmetrical form, means I will make this LR to LL. So how to make? I will touch only this part. I will rotate only this part. If you are rotating this part, what I will do? I will come here. I will rotate. So at first I have 8. Then second LL. I am making LL. Okay. So I am making LL. So my 8 is same position. So whenever rotation is there, 7 will come and 3 will come. Okay. So now you can see this is L and this is also L. This is LL. Okay. After then I want to rotate. I will rotate. This is clockwise direction. If I will rotate clockwise direction, then after then your 7 will be here and your 8 will be here and your 3 will be here. Now you can see, according to the BST property, 7 is the root and 3 is the left element and 8 is the right element. And you can see my left element is smaller than root and my right element is greater than root. Okay, that is the BST, binary search tree. Okay, this is first. This is very important. If you know this one, then easily you can understand how to delete in AVL and in RBT and BST. Okay, now I will come here another example. Suppose I have given you in exam, I have given you this is right and this is left. Okay, again I want to rotate it. So what I will do, at first I will touch only this part. So why? Because this is RL, this is RL. I will make this is RR, symmetrical form, RR. So what I will do, I will rotate. RR means I will this 3, then 6, then 4. What is this? I will fill the data. So if you are rotating, I told you have to touch only this part. So 3 is same position, but 4 and 6 they will swap. Done. After then you will use, whenever there is a RR, you will use anti-clockwise direction. Rotate anti-clockwise direction. So your final outcome will be, like this. Okay, your final outcome will be like this. 6 is same position, 6 is same position, and 4 is here, but your this 3 will come here. Now you can see this is now BST, binary search tree. You can see my left is smaller than root. Okay, my root is 4 and my right is greater than root. Root is 4. So this is BST. Okay, so if you know how to rotate, okay, if you know how to rotate, then easily you can understand the AVL as well as the red black tree. Okay, now I will come one very interesting question. Now you can see that my 8 is the root. Okay, 8 is the root, and this is the right element, this is the right element, and these are all the left element. You can see 3 is smaller than 8, 1 is smaller than 8, 4 is smaller than 8, and 6 is smaller than 8. So and 10 is greater than 8, 10 is greater than 8. So this is the BST. Okay, now you can see again 1 is smaller than 3, and 6 is greater than 3, and 4 is greater than 3. So this is also, so every time your left must be greater, sorry, your right must be greater and left must be smaller than root. You have to follow the property for each node. That is the meaning of binary search tree. Now I will come here. So how to searching, I will discuss about the searching. Insertion is same. Okay, suppose you want to search for, so how to search for? You will start from here, 4 is smaller than 8, I will go this side. 4 is greater than 3, I will go this side. 4 is smaller than 6, I will go this side. So I search operation. Same also, if you want to insert another element, you have to use same property. Okay, now I will discuss about the delete, because delete is very important. Okay, I will discuss about the delete. Case number one, if you want to delete any node that is the leaf node, direct delete, no problem. Case number one. Okay, case number two, if a node has one child, and you want to delete this 6, how? So what you will do, you will swap, means I want to delete 6, 7 will come here. Okay, 7 will come here. Now both are 7. This is also 7. I want to delete 6 and 7. Now I will delete this one, because leaf node easily we can delete. Okay, I deleted 6. Very simple. Okay, now next, suppose a node has 2 child. Okay, suppose a node has 2 child. Okay, now suppose you want to delete this 3. So you have to remember one property, successor and predecessor. What is the meaning of successor and what is the meaning of predecessor? I will say you something. Now listen, this is the left subtree. In the left subtree, the rightmost element is the predecessor for this 8 root. Done. Understand? In the left subtree, this is the rightmost element. This is 7. Is the predecessor for this root. Done. And same thing also, successor means that is smaller. I will show you. what is the meaning of successor? If I have written any example, and here I have not written any example, so I am writing this example here. So I will write here. Okay, suppose you know that less than 10 is 9. Okay, less than 10 is 9. Okay, now what is this? What is this? This is my right subtree. In right subtree, the smallest element is the successor for this 8. This is the successor and this is the predecessor. Done. Because this is the, because why this is the predecessor? Because this is in left subtree, the maximum element is 7. The max element in left subtree is the predecessor and the minimum element in right subtree is the successor. If you understand this property, then you can easily understand how to delete in case number 2. Okay, in case number 3. In case number 3, I want to delete. What I want to delete? I want to delete this 3. So I will check who is the, now you can see this 4, this is the, what is this? This is the right subtree and this is the left subtree. There is no predecessor. So I will take successor. 4 is the successor. 4 is the smallest element in right subtree. So 4 is the successor. Either take successor or predecessor. So I will swap both and I will cut. Very simple. Now see what is this. I will swap this and this and I cut. Done. 4 came here. Okay. So there are only 3 methods to delete in BST. This property we have to use in RBT and other also. Okay. So one problem in BST. What is the problem in BST? Generally the BST time complexity is order of n in every case, but sometimes its time complexity is order of n. Why? Okay, now see here, suppose I have this element 1 and 2 and 3. Okay, I will insert at first 1. Okay, then I will insert 2 because 2 is the greater than 1. Okay, then I will insert 3 because 3 is the greater than 1, 3 is greater than 2. Now you can see this is actually behaving just like singly linked list. So if you want to search 3, so you have to transverse all element, 1 from here, 1 from here. Total elements are 3, time complexity is 3. Total comparison are 3, time complexity is order of n. Okay. Now second, suppose you have this element. Suppose you have 4 and 3 and 2. Okay. At first I will insert 4. Okay. I will insert 4. Okay. Done. Then I will insert 3 because 3 is less than 4. Okay. Then I will insert 2 because 2 is less than 4 and 2 is less than 3. Now you can see this is the left skewed tree. This is the left skewed tree. So again, if you want to search 2, then time complexity is order of n. So whenever data is sorted, time complexity is order of n. This is the biggest problem in BST. So how to solve this problem? By the help of AVL. This is the balance tree. Okay, there were 3 researchers, Adelson, Walensky and Lindroff. These people, they describe a new tree that is the name of balance. How to balance a tree. Okay, so you have to remember one line. What is the line? The left subtree height. Left subtree height or minus right subtree height mod is less than equal to 1 every time. This is the property of AVL tree. Okay. Now what is this? I will explain. Now in the classroom already we discussed and how to use the backtracking and so these problems you should and also we upload such type of programs in our previous video. You can go and we solved. Also we explain how the swapping method is working and how the creation and how to insert the elements in a tree, and how to use the pre-order, in order, successor, predecessor, and how to delete the data, and how to insert the data, how to create the node, everything, all type of programs we explain in our video. You can check insertion in classroom also, okay, and how to delete is working, same problem we have written. Now here we will not discuss, because already we discussed, okay. Now we are coming here the next topic, the next topic is AVL tree, okay. So now we have, suppose this example. I am taking one smallest example. My example is, suppose my example is 10. I am taking a small example, easily you can understand. I am taking 18, okay, 10, 18, and I am taking 7, I am taking 15, I am taking 16, and I am taking 30, and I am taking 25, okay. These are my data, and I have to use AVL, okay. AVL already we discussed, again I am using. So if you know the rotation, okay, already we discussed, if you know the rotation, so easily you can insert the data in AVL. So at first you will insert 10, okay, this is my first data, I will insert here, done. Now next, 18 is greater than 10, I will place here, done. I will find also the height every time. You will insert as same time, you will also find the height. Here height is equal to 0. Every leaf node height is equal to 0. Now here there is no data. So height is equal to, there is no data, no height, 0. Left subtree 0 minus right subtree data is 1. So height is equal to 0 minus 1 is equal to 1. So you can see height here is 0 and here is 1. So this is a AVL tree. Okay. Now next, I will insert the next data, I will insert 7. So what I am doing, first it was 10, second it was 18, now next data is 7. 7 is less than 10, so I will place here. What I told, every element, every leaf node height is equal to 0, okay, every leaf node height is equal to 0. Now I will find height for 10. So height is equal to 1 minus 1. 1 minus 1 is equal to 0. So now you can see height, here height is 0, here height is 0, here height is 0. So this is balanced tree, AVL tree. Now my next data is equal to 15. So 15 means 15, where the 15 will come, 15 is greater than 10 and 15 is less than 18. So 15 will come here, okay. Now I will make another tree, so easily you can understand. So my previous data was 10, my previous data was 10, my previous data was 7, my previous data was 18, and my new data, that is, what is the new data? My new data is 15. So 15 will come here, 15 will come here. Where 15 will come here, 15 will come here, 15 will come here, because this is less than 18. Now after then I will check the height, So now you can see every leaf node height is equal to 0. Every leaf node height is equal to 0, done. Now I will check here. So here height is equal to 1, here height is equal to 0. So here height is equal to 0 minus 1 is equal to, 1 minus 0 is equal to 1, done. Now here height is equal to 1, here height is equal to 1. So left height is equal to 1 minus height is equal to 2, height is equal to 2. So 1 minus 2 is equal to 1, because this is more, okay. So now next, so up to this, okay, no problem, height is less than 1. Now I am coming here. Now my next data, this is very important, my next data is 16, okay. So 16, 100% 16 will come here. How? So my previous data was 10, okay. Now next data, previous data was 7, okay. Now my previous data was 18, okay, 18, and previous data was 15, Now my new data is 16. So 16 is greater than 10. 16 is smaller than 18. 16 is greater than 15. So 16 I will place here. Then what is my task? Then next task is I have to find the height. I told height at leaf is 0. Height at leaf is 0. Done. Now what is the height here? Here 0 minus 1. So height is equal to 0 minus 1. Here height is 1 is equal to 1. Again I will check what is the height here. Height is equal to this is 1 2. Height is equal to 2 minus there is nothing 0 is equal to 2. Now stop. Problem is here. So now you have to remember one thing. Okay, this is very interesting topic. So whenever there is a problem, I insert the data here. My program is here actually. My code is here. Okay, means my pointer is here. So I will take this part. This is my problem. I will take this part. At first I will solve the problem here. What I will do? I will write this 18. I will write this 18 here, and I will write this 15 here. I will write this 15 here, and I will write this 16 here. I will write this 16 here. So before start the lecture, I told this is my L and this is my R. I will make this LR to LL. Okay, so I will touch only this part. Okay, now what is the meaning of this? This is my 18. Okay, then 16 will come here. 16 will come here because we have to touch this one, and 15 will come here. 15 will come here. Now what is this? Now this time, now this is my L and this is my L. I made LL. So whenever LL is there, I will rotate clockwise direction. So in this condition, your 16 will come here, and 15 will come here, and 18 will come here. Okay, now once you solve the problem part, then you will attach the problem part here. Where? Here. So now I will go my previous data. My previous data was 10 and 7. Okay, my previous data was, this was 10 and this was 7. It was my previous data. So the problem I attach here. What was the problem? I solved. It was 16. Okay, then it is 15. This is 15 and this is 18. This is 18. So now again I will check. What is the height. My height at leaf node is 0. My height at leaf node is 0. My height at leaf node is 0. Now I will check what is the height here. Okay, so height is 1 minus 1. 1 minus 1 is equal to 0. Now next I will check what is the height here. So 1 minus, either you check 1 2, here also 2. So height is equal to 1 minus 2. 1 minus 2 is equal to 1. Now easily you can track. What you can track? My height is 0 here, height is 0 here, height is 0 here, height is 0 here, height is 1. So every time height is less than equal to 1. Okay, it means that this is the AVL tree, this is the balanced tree. Now my next data, what is my next data? My next data is, you should write in a copy. My next data is equal to 15, 16. Now next data is equal to 30, then 25. Remember, 30 and 25. Now we have to insert 30 and 25. I am writing here. I have to insert 30 and 25. You have to learn only some step. So 30 is greater than 10. 30 is greater than 10. I will come here. 30 is greater than 16. I will come here. 30 is greater than 18. I will come here. So now I will check again. So what I will do, I will come here. This is my 10. Okay, this is my 10. Then 7, 16. Then this is my 7, and this is my 16. Okay, 16, and then 15 and 18. This is my 15. This is my 15, and this is my 18. So now already I told my new data is 30. My new data is 30. So 30 will come here. 30 will come here. Then after insert, I will check what is the height. I will check what is the height. So my height is equal to 0. My height is equal to 0. My height is equal to 0 because these are the leaf node. Next, what is my next target? My next target is I have to check the height of other. Okay, now see here, this is done. Okay, this height is equal to 1, this height is equal to 1, this height is equal to 2. So height is equal to 1 minus 2. 1 minus 2 is equal to 1. Okay, again this is also 1. Now I will check the height here. Where? I will check the height here. Height is equal to, this is 1. This is 1. 1 minus max height. 1, 2, 3. 1 minus 3 is equal to 2. So problem is here. So now I insert the data. I insert the data from this part. Okay. So what I will do? I will take the problem part. My problem part is this. I will take these 3. So what is this? This is R. RR means I will rotate anti-clockwise direction. What is this now? See here. So what I will do, I will rotate this injured part. My injured part is 16. Injured part is 16, done. Okay. And 18 is this. I will rotate this. 18 is this. I will rotate this. And I will rotate anti-clockwise 10. These 3. Okay. Anti-clockwise is 10. Done. Okay. Now remaining part I will attach. 7 is the left of 10. So 7 is the left of 10. So it is left of 10. Okay. Now 30 is the right of 18. 30 is the right of 18. 30 is the right of 18. Done. Now listen, this is very important now. This is very, very important. What very, very important? This is very, very important. And 15 is left of 16. This is very important. 15 is left of 16. What is 16? 16 is this. 15 is left. So 15 is greater than 10. So it will come here. Now I will check height. I will check height. What is the height? So I told leaf is equal to 0. Leaf is equal to 0. Leaf is equal to 0. Now what is the height? Height is equal to 1 minus 1 is equal to 0. Height, this is 0 minus 1. Height is equal to 0 minus 1 is equal to 1. Now here height is equal to height I am using another color. Height is equal to using another color. Height is equal to 1, 2. Okay, or this also max height. So 2 minus 1, 2 is equal to 0. So you can see that every time my height is less than, height is 0, height is 0, height is 0, height is 0, height is 1, height is 0. So this is a AVL tree. So similarly you can insert all the data in AVL tree. And deletion. In AVL tree the deletion is similar to BST. Now if you want to delete any data, in AVL tree, what you will do? You will use same method. What method? The property of BST. The property of BST. Now see here, suppose I want to delete this 115. So I told there are 3 cases. Case number 1, leaf node directly delete. Then after use the AVL property, means a rotation and this property to balance it. Okay. And if you want to delete this 16, and what I will do, what I told, it has 2 child. I will use successor predecessor. Okay. Suppose you want to delete 10, I will use successor predecessor. So here successor is equal to 15. Both will swap, and you will delete. Then after you will balance it. So AVL is very, very simple if you know the BST. How to delete in BST? Delete by the help of BST property, then balance it using this method. How to balance already we explained. So I think that you understand. Now after we are coming, this is very, very important. This is the red black tree. Red black tree, you have to remember, I already told red black tree. What I told, red black tree means every new node is red, number first property. every new node is red. If it is root, then this is black. Done. Second property, suppose there is another, if it is a root node, then this is the black. Done. It is a black. Now whenever you are inserting another new node, that is the red. Another new node, that is the red. Okay. In every branch, total number of black must be same. What is the meaning of this? Total number of black must be same. So you can see I am writing here total number of blacks are 2, total number of blacks are 2, but here only one black. So this is not RBT. So if you want to make this RBT, you have to make this is black. Now this is RBT. Now this is RBT. Done. Now third, if the two adjacent nodes should not be red. If it is red, then problem. Okay, this is not RBT. To make RBT, how? Now I will explain. So what I told, every new node, this is my data. My data is 10. Okay, every new node is red. Done. But it is what is this? This is the root node. So this is black. Okay, this is the first method. This is the first method. Now second, every new node is red. Second data is 18. 18 is greater than 10, so I will place here. Okay. Next data is 7. 7 is less than 10, so it will come here. This is the new node, so it is red. Done. Next, my next data is 15. 15 is greater than 10. Okay. 15 is less than 18, so it is left side. Every new node is red, so this is red. Problem. What is the problem? Both are red. So whenever there is a red, what you will do? You have to use some property. Okay. So what is the property? Now listen here. This is your child. This is your parent, and this is your sibling. Check the color of this parent, sibling, and child. The color, there are only two methods. This method is R. This color is R, this color is R, and this color is R. Means sibling, parent, child, all color are R. In this condition, what you will do? You will change the color of parent, you will change the color of sibling. This color is same. What is the meaning of this? To make it red black tree. So this will be black. Done. Now this is red black tree. You can see this branch also 2 black, this branch also 2 black. Done. This is a now RBT. Done. Now next I want to insert 16. I want to insert 16. So what I will do? My first data was 10. Okay, and next previous data was 7, and then next data was 18, next data was 15, next data was 15. This is 15. Okay, now my new data, I insert a new data. This is 16. So 16 is greater than 15, 16 is greater than 10, 16 is less than 18, and 16 is greater than 15. So I will place 16 is here. Now listen here. What was the color? Previous the color was 10 was black. This was black. Previous the color was black. Okay. Previous the color was 7. Previous the color was 7. Okay. Now next. Previous the color was 18. It was black. Okay. This is the previous data. Now I insert new data, that is 16. 16 is red. Now again problem came. What is the problem came? I got both are red. Problem came. So this problem, how to solve? I will check what is this method. Now see here. This is my child. Okay. And this is my parent. And this is my sibling. Sibling is null. So null means a black. Done. Even there is a data black. Okay. So what is the problem? The problem name is RRB. The problem name is, this is R, red, 16 is red, and parent is red, child, this sibling is black, RRB. Whenever there is a RRB, what I will do? Only two methods are here. What I will do? I will take the injured part, means I will take this part. This is my problem. This is my problem. This part I will take here. I will take here. This is my 18. Okay, leave it. What is the color? 18. Okay. Now after then 15. After then 15. After then 15. This is my 15. 15. And this is my 16. This is my 16. Okay. Now what is this? What I told at that time. This is my this is my L and this is my R. So rotation. Whenever RRB, rotation. RRR, change the color. Now I will make this is LL. I will make LL. So I will touch only this part. So what is the meaning of this? This is my 18. Okay. And this is my 16. Okay. And this is my 15. I told you have to swap these two. Okay. If you are rotating like that to make left. Then you have to use the you have to use the clockwise direction. So this is now LL already I made. Okay. Now what you will do? This is your 16. This is your 16. Okay. Now this is my 18 is here. 18 is here after rotation, and my 15 is here after rotation. Done. Okay. Now next I will check what was the color. I will check what was the color. Okay. Now listen here. Before, when I did this one, properly listen here. Now see what is going on actually. What is going on here? This is check. So 15 is here. 15 is here. Okay. Left of this. And after then see, after 15 is left side. 15 is left side. After this also 15 again left side, again 15 left side, means 15 did not change the position. Okay. Now but when I use this one, this 16 was somewhere, it was left actually, but 16 came this position at root position, and 18 was at root position, it came this position. So these two people, these two data, they change their position. What I will do now, listen here, very important. Okay, after then what I will do, I will attach this part here. Where? Here. So at first I will write 10. It was 10. It was 10. Okay. Then it was 7. Okay. And I will attach the part here. This part I will attach here. 16. Okay. This is 15. And this is 18. This is my 18. Now listen here properly. So I will write the color. What was the color? It was both black. Okay. Both are black. No problem. Both are black. Both are black. Now next previous it was your 15 and 16 were red. 15 and 16 were red. 15 and 16 were red. This was red and this was red. Both were red. Okay. Now who changed the position? 15 did not change the position. 15 did not change the position. So 15 is okay. I will not touch this part. Okay. I will change the color of these two. Okay. What I will do? I will change these color of two. So 18 will become red. 18 will become red. I am writing. Okay. If you are not able to understand, 18 will become red. Okay. And 16 will become, 16 was red. Okay, 16 was red. Now 16 will become black. 16 will become black. Done. 16 will become black. Okay, and this is red. Remember, this is red. This is red. This is red. Now see here. How many blacks are here? How many blacks are here? There are total 2 black. There are total 2 black. 1 black, 10 and 16, and both are red. Done. So this is a what is this? This is there are only 2 property. Okay, there are only 2 property to make the red black tree. One is RRR, to insert the data in red black tree. One is RRR, second is RRB. Only 2 property. RRR, RRB. In RRR, change the color of the parent and sibling, and in RRB, you have to use the rotation property. I told rotation property is very important. Now, how to delete the data in red black tree? Rule number 1. I told, if you know BST, then it is very easy. Number first, if the node is red, if you want to delete any node and the node is also red, delete red node, no problem, direct delete. Because problem, what is the problem in BST, in red black tree? Total number of black in every branch, total number of black in every branch must be same. So black you cannot delete, red you can delete direct, red you can delete direct. So what is the meaning of this? This 20 I can delete direct, done. Okay, now second, suppose you want to delete 20, suppose you want to delete 20, okay, even it is red something, okay, leave it. Okay, so if you want to delete 20, what you will do, you will use the child property. It has only one child, it has only one child, so I will swap both, I will swap both and I will delete, done. So when you will swap, you cannot change the color, remember. So I swap 20 and 30 and I delete, done. Okay, before it was red, before, if you will see, just go to the back video, before it was black. Okay, I want to delete 20, so what I will do, I will swap and it red I can delete, red I can delete, easily red I can delete, done. Okay, so very easy I can delete, no need. Now next, suppose it has a two child, okay, it has a two child. Now you can see, I want to delete 30, 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 I want to delete 30. 30 has two child. So what I will do? I will use successor. I will use successor. Both will swap. These both will swap. Both will successor, predecessor. Okay. So 38 will come here and 30 will come here. I want to delete 30. So both are 38. Both are 38. Then I can delete red. I can delete red. You can see I have not written here. So if you want, I can make. So this 38, this 38, it is red. So this 38 will come here, 30 will go. I want to delete 30. So after then 30 will come here, 30 will come here. So 30 will come here, 38 will come here in place of this, 38 will come here. Then after then I can delete, because this is red, I can delete this one, done. So we are using the property of BST. Problem. When the problem will come? Problem will come when there is a black. Okay. So for the black, there is only one property. First we are discussing double black. Okay. If you want to delete double black, means if you want to delete, suppose I want to delete this 15. If I want to delete this 15, how to delete this 15? This is a black. Black I cannot delete. I will show. So I have written something here. If you want to delete the black, at first make it double black, then check what is the color of the parent. If parent color is red, then convert it black. If parent color is black, then make it double black and make sibling red, and do this until you are not getting the solution. Now listen here, what is this? This is your problem. So here all are black, all are black initially, all are black. This is also black, 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 30, 20 is also black, and 10 is also black initially. And I want to delete this 15. I will make it double black. So this is my double black now. This is my double black. This double black will transfer here. It will transfer here. Done. Okay. So this is already black. This is already black. Now this double black will transfer here. This will transfer here. Done. Okay. So when the double black is transferring, it will change the color of, it will change the color of sibling. It will change the color of sibling. So your sibling was black, now it will be red. Whenever double black transfer, so your double black transfer, then change the color of sibling. Your double black transfer, change the color of sibling. Okay, change the color of sibling. And once the double black is root, then remove the double black to black. Done. You got the solution. And at last, cut this one. Cut this one. Done. Now you can see at this branch, I have one black, two black, one black, two black, and one is root black and 20 is black. So every branch, two blacks are here. Okay, this because we already cancel this one. This is the first property. If you are not able to understand, again I will explain. Okay, so if you are not able to understand, again I will explain you very easy method. If there is a space, okay, I will say here. Now see, I am using very beautiful method. Okay, what I am doing, I will do, this is 1 2 3 4 5 6 7. Okay, all are black. Okay, now see here what I told. If you want to delete this one, you want to delete this one, I will make double black. Done. I made double black. This double black will transfer here. This double black will transfer here. Done. So now if you transfer here, then this will be red. This will be red. Now this double black will transfer from here to here. This double black will transfer from here to here. So now it will become double black. It will become double black. So whenever transfer double black, then after then its sibling will be red. Sibling will be red. This is red. Okay. This is a this is the root node. Now it will become the black. Done. Now you can see in every branch the total number of blacks are same. So this branch total blacks are 2, this branch total blacks are 2, this branch this already deleted, this branch only 2 black. Even you are not able to understand, again I am doing this another example. Suppose I have this one example, here is no space, again I will here. Suppose I have this one, 1 2 3 4 5 6 7 8 9. Okay, here also 10, here also all are black. Because if all are black, no problem. Okay, so this is red black tree. Now listen here, I want to delete this one. What I want to delete? I want to delete, suppose this one. I want to delete this one. What I will do? At first I will make a double black. I will make this one double black. I will make double black. This double black will transfer from here to here. Okay, it will transfer from here to here. Done. It will transfer from here to here. So once it is transforming from here to here, what will happen? Transfer from here to here. Then your sibling will be red. Your sibling will be red. Done. Okay, transfer from here to here, sibling is red. Again this black will transfer from here to here. Okay, this will be black. This is double black. This is double black. So now what will happen? Double black means sibling is red. Sibling is red. Done. Now again this is this double black transfer from here to here. So this is double black. This is double black. And your sibling will be red. Your sibling will be red means this is red. Okay, now this is red. Done. Now done. Okay, now this is a what is this? This is my root. So root, now it is make it single black. Done. Now see here, I will count. At last cut this one. At last cut this one. Now I will check how many blacks are there. Now see here, this branch 1 black. Okay, root is 1 black, 2 black, 3 black. This branch 1 black, 2 black, 3 black. This branch 1 black, 2 black, 3 black. This branch 1 black, 2 black, 3 black. Now I am using another color. This branch 1 black and 1 and 2. Root and this one 2, 3. Okay. This, and if you go this branch only 3. 1, 2, 3. This branch 1, 2, 3. This branch 1, 2, 3. So every time there are total number of 3 blacks are there. So this is the red black tree. Okay. So double black property you have to remember. If you know, and other thing you have to use the property of the BST property. Okay. I think that you understand. There is also another one. This is if it is parent is BBB. Okay. BBB already we explained. Okay. And there is another property. I will see any other property. I think that we explain all the property easily. Successor, predecessor you have to use. So if you want to delete this 30, you have to use the successor predecessor property. Okay. So you can see 30 and 30 both are changed, and after then 35, 30 and if you want to delete 30, 35 will come here, 30 will come here. Okay. After then this is RRR, this property. So again we delete. So all are similar. You can check also. You have to understand only the Already we explained also in classroom also dV and some property of BST property. Now I will go, I will not waste your time. I will go the interesting topic. What is the interesting topic? My interesting topic is B tree. So in B tree also I told, in B tree you have to remember some property. Number first, what is the meaning of, listen, oh sorry, number first, what is the meaning of this? In this also BST. Here you can insert many data in one node, number first. So these are the child, these are the child. This is the key, key. Okay, this order means 3. This is the order. How many elements I can insert? Order. How many elements I can insert? So these are the child. Okay, in one node we can insert many data, but there are some restrictions. The restrictions I will teach you. Suppose I have this data. 5, 3, 21, 9, 13, 28, 7, 10, 11 and 14, 8 and 16. And my order is 4 given. So maximum key is equal to formula m minus 1. Means 4 minus 1 is equal to 3. Minimum key is equal to upper floor m upon 2 minus 1. So 4 upon 2 is equal to 2 minus 1 is equal to 1. And maximum child is equal to m. Okay, here 4, okay. And minimum child is equal to m upon 2. So m upon 2 means 4 upon 2 is equal to 2. So this formula you have to understand. According to this I have to go here. Already we explained how to insert the data. At first your data is 1, 2, 3, 4, 5, 6, 7, 9, 10. So at first you will insert, I will insert 1 because of 1 is, then I will insert 2, then I will insert 3. Maximum how many child I can place, how many key I can place, key is 3 only. So more than 3 is not possible, So once 4 is coming, 4 is means overflow. So I will take the mean, of 1, 2, 3, 4. So 4 upon 2 is equal to 2. So I will split this part. So what is the meaning of this? I will split this part. So this 2 will go above and 3 and 4 will be left side. So 2 is here and 3 and 4 are here. And 1 is the left of 2 and 1 is the left of 2. So maximum data is equal to 3 in one node. Done. Now next data is 6. Next data is I insert 4. Okay, after then insert 5. Done. Now when I insert 6, overflow again. So once overflow, so mean, I will take mean, I will split this one. So there is already space, this 4 will come above. What is this? I will show you. So 4 I will split. Okay, I will split 4 will come above because there is a space. Okay, now after then I will insert 7, I will insert again, the data is overflow, I will take the mean, so it will split, so 6 will go above, so there is already space is there, so 6 will come here, so 6 will come here, and 7 and 8 will be the left of 6. So left of 6 is equal to 7 and 8, and 5 is the less of 6. 5 is less than 6. So 5 will be the left side of 6. And total elements are 3. So similarly we will insert other element also. Suppose I want to insert 10. So 10, again this is overflow. So again this is a mid part. I will split, the 8 will go above. So 8 will go above. 8 is coming here. Okay. You can see here I split. So this is not possible. So what I did, from here 8 will go above, 8 will come here, this is also overflow, again split this one, so again split this one, you can see, again split this one, so 4 will come above and 6 and 8 will be left side. 4 is above and 6 and 8 left side, and 2 is already there. 2 is the left of 4, and you can see in the previous data 1 is left of 2, 1 is left of 2, done. And you can see 3 is the right of 2, so 3 is the right of 2, so proper you have to place according to the BST. And you can see, and 5, what about 5? 5 was left of 6, 5 was left of 6, 5 was left of 6, and similarly 7 was greater than 8, greater than 6, 7 was greater than 6, you can see greater than 6 is 7, 8, but I split here, so I split here, 7 is coming here and 9, 10 are coming here. So this is very means a very simple method, already we explained last time in the classroom, and also video lecture we sent. Now how to delete? How to delete? This is the question. So how to delete? I have another example here. My order is equal to 5, number first. It's depend on order. Second, my maximum key is equal to m minus 1 is equal to 4. Minimum key is equal to m upon 2 minus 1 is equal to 5 upon 2 minus 1 is equal to 2. Minimum child is equal to 3 and maximum child is equal to 5. Now, you have to remember this property. This is the upper floor, upper part. Okay, 5 upon 2 is equal to 3. Upper, not lower. And this is lower. What is the meaning of lower? And what is the meaning of? Actually, there is two function. What is the floor and one is ceiling. Okay, so this is ceiling function, you can say. Now, if it is a leaf node directly you can delete, no problem. But you have to check according to the order. Okay, what is the minimum child must be there? 3. Now listen here. If you want to delete 64, direct delete, no problem. Why? Because your minimum key is equal to 2. Means there must be at least 2 key must be there. Okay. So if you want to delete 64, directly you can delete 64, no problem. Because there are 3. I want 2 minimum. I want 2 minimum. I can delete. Now if you want to delete 23, now this is not possible. Impossible, because there are total number of only 2 data. My minimum requirement is 2. Cannot possible. How to delete 23? So whenever you want to delete 23, you will ask, give me borrow. So you will ask to this is neighborhood node. You will ask if you have more than 2, then give me. So this will go above, and after then this 20 will come here. So now you can see your 16 is here, your 16 is here, and your 20 it will go left side, 20 will go left side, done. And your 23 deleted. Now you can see here also 2, here also 2, and here is your 3, and here also 2, no problem. So minimum key requirement is 2. Okay, this is the formula. Now second, suppose you want to delete 72. Now you can see 72 is not possible because total elements are 2. If I will delete, then 1 only. Okay, that is violating the property. So what I will do? I will ask the neighborhood. Neighborhood has 3. Neighborhood has 3. So he will give me this 77 here, and this 75 will be come here. Then I can delete 72. Now you can see my 77. My 77 came here. My 77 came here, and my 77 came here. 75 will come here, 75 will come here, 75 will come here. Now after then I can delete easily, and there are no one is violating the condition. 78 and 79, 78 and 79. Now you can see easily I deleted. Now there is another case. If you want to delete 65, okay, so if you want to delete 65, here we have written something. Okay, if you want to delete 65, now see here what is the problem here. If you want to delete 65, now listen here. I want to delete 65 here, but neighborhood it has only 2. Okay, and its neighborhood it has also 2. Problem, he cannot take borrow. So in this condition, what I will do? I will take the merge method. What is the meaning of merge method? Now listen here. So in this condition, I will merge. I want to delete this one, so it will go above. It will go above. Okay, I will merge. So now what is this? 60, 70, 77, and this 65 and 68 will come above. 65 and 68 will come above. Before it was these two will merge. This is also merge. Okay, these two will merge. So 51 came here, 51 came here, 52 came here, 52 came here, and 60 also is there, 60 also there, and 65, 65, both are merged, and 63, 63. Okay, means I merge these two. I merge these two. Merge. Okay, I merge, and 60 in place of 60, है ना? So 60 I want to delete. What I want to delete? I want to delete 65. So once I merge, okay, once I merge, so now you can see before the data was 70 and 77. This data is 70 and 77 is there. Okay. Now I merge these two. Okay, I merge these two and delete 65, place 60 here. Okay, what is the meaning of this? Now you can see. So merge property you have to follow. So what I told, if you want to delete any data, if it is more than number of the minimum key data, okay, means there are total number of at least are 2, and if it is more than 2, then you can directly delete. If it is not less than 2, then you will take borrow, है ना? So, and if both neighborhood has not less than 2 in this condition, you will merge. I merge. If you are not able to understand, again I will explain you. Now listen here. Suppose I want to delete 20. Suppose I want to delete 20. Suppose I want to delete here. This is very good. Suppose I want to delete 20. Now you can see 20 I want to delete. Okay. So now you can see this is impossible because neighborhood there is no one and this is only one and I cannot delete. So both will merge. Both will merge. Both will merge. So what is the meaning of this? Then I can delete. So both I merge 14, 15, 27. 14, 15, 27. 14, 15, 27. I delete 20. So when I merge at that time, this also coming because I merge these three actually. I merge these three. Okay. So what is this? 16 will come here and this. Getting? Very simple. So whenever I merge, here also I merge. So whenever I merge, so this also participating. Okay. This and this. Now if next there are only three property: merge, take loan from left side, right side. If it is it has more than, if it has more than, suppose you want to delete 14, directly delete, done, no problem. If you want to delete 15, direct delete, no problem. If you want to delete 51, direct delete, no problem. If you want to delete 60, no problem. If you want to delete if you want to delete 5, no problem. Okay, no problem, because more than 2, है ना? But if it is less than only 2 or less only 2, है ना? So in this condition you will take borrow. Okay, and if both have less than 2, then you will merge. So you can take the loan from here, it will come here, then it will come here. Okay, here already one, again I am merge. Okay, because it has only one merge. Okay, so there are only three property. First property is, again I will teach you. First property, if you want to delete 79, delete, done. If you want to delete, done. If you want to delete, done. Okay, if you want to delete, done, no problem. But you have to check the BST property. Okay, and if now it have both have here also 2, here also, here 3, and if I want to delete 14, I want to delete 14. So what I will do? If you want to delete 14, what you will do? This is not possible, because it has 27. So I will take borrow. This 6 will come here and 10 will come here. Then I will delete this one. So very easy. I think that you understand. So take borrow and or merge. There are only three methods. Okay, there are only three methods. So you can check the data already we send in your description box, as well as available there also. Okay, so I think that you understand. Okay, so there are three property: merge, and second, take loan. Third, if it has more, direct delete. More, direct delete. More, direct delete. More, direct delete. Okay, here not possible. This here, if you want to delete 5, not possible. So this 14 will come here, 10 will come here, then delete. Very simple. Okay, so take loan, merge, and third. What is the third property? Third property is direct delete. Now I will come to the heap. Before starting the heap, I will explain what is complete binary tree. Now you can see I have some data 6, 4, 1, 12, 3, 8. So one data, and this is 2, and this is 3, and after then how I will fill the in heap tree: 1, then 12, then 3, then 8. So what is the complete binary tree? Complete means at first you will fill the data here, so 6 will come here, then second data is 4, you will fill here from left to right, okay, then 1 will be here from left to right, then from here, what is this data? This is 1, then after then 12 is here, then from here to here, this is 3, this is 3, from here to here, this is 8, this is 8. This is the meaning of complete binary tree. Complete binary tree is working from left to right. Now second, minimum heap and maximum heap. What is the meaning of minimum heap and maximum heap? Now you can see I have some value here. This is suppose 2, this is 2, and this is 9 and 5, whatever, you can write something. Now if parent is smaller than child, that is the minimum heap. Okay, now next, what is the next? If parent, this is a parent and it has 2 child, okay, and if a parent, and suppose the data is 10, suppose, and what you can write anything, okay, and this is 2 and this is 1, you can write, there is no restrictions left and right. Now you can see your parent is greater than the child. This is the maximum heap and this is the minimum heap. Done. If you know these three, then easily you can make the heap tree. Now see here what I am doing. My first data is 6. Okay, my first data is 6. My first data is 6. My first data is 6. So I can use this method also. I am using this method. I am not wasting your time. Okay, that is the heapify method. Heapify method means, what is the meaning? At first you will count the data. How many data are there? 1, 2, 3, 4, 5, 6. Okay, 6. So I will make 6 node. 1, 2, left to right. 1, 2, 3, 4, 5, 6, left to right. Now I will fill all data from left to right. I will fill all data from left to right. My first data is 6, 4, 1. I will write 6, left to right. 6, 4, 1. Now next 6, 4, 1. Then after then 12, 3, 8. 12, 3, 8. I am writing 12, 3, 8. Okay. Now we are working let for the maximum heap. Let maximum and minimum both are same. Suppose I am working for max heap. Let I am working for max heap. Okay. Now what I will do, I will start at first. Remember, I will never touch the leaf part. Number first, I will never touch. Now I will come from, either you can come from right to left or left to right. Okay, I am coming from, okay, I am coming from here. I am coming from here. At first I will ask this person. This root will ask both a child. There is no child, okay, leave it. So this will ask, I want a max heap. This will ask, one will ask, who is greater? 8 is greater. So both will swap. What is the meaning of this? Now listen here. What is the meaning of this? 1, 2, 3, okay, 4, 5, 6. Done. So my first data was 6. My first data was 6. I will write 6 here. Okay, done. So now my next data was 4. Next data was 4. I will write here. My next data was 12 and 3. I will write 12 and 3 here. So this one asked to 8. Who is greater? 8 is greater. So both will swap. both will swap. So both will swap. So both will swap means 8 will come here and 1 will come here. Done. Next this 4 will ask both child. This 4 will ask both, who is greater? 12 is greater. Both will swap. Done. Now what is the meaning of this? My next is 6 here. Okay. My 8 is here. Okay. My 1 is here. Okay. Now next I am not writing here. Okay. This and this and this. Who is greater? 12 is greater. 12 is greater. 12 is greater. You can 12 is greater. I will 12 right here. 12 right here. And 4 is here. And 3 is here. Done. Now after then, once the lower level done, now this 6 will ask to both child. This 6 will ask to both child. Who is greater? 12 is greater. Both will swap. Done your problem. Now see here what is going on. I am writing here. So my problem solved 1 and 1, 2, 3, 4, 5, 6. Okay. So what I have done, this already done 4, 3, 1. I am writing 4, 3, 1. I am writing this is 4, this is 3, this is 1 already done. Okay. Now after then this 6 ask both, who is greater? 12 is greater. So 6 will come here, 6 will come here, 12 will come here. Now next this data is already 8 is there. Okay, done. Now you can see this is a max heap. Why this is a max heap? Because the parent is greater than both. Okay, parent is greater than both. Okay, parent is greater than this. Done. This is the max heap. Similarly, you can design the minimum heap also. Okay, very simple. Same. If you want, I can also draw minimum heap also. What I will do? Very simple. What is my data? My data. I will write my data. My data is 6, 4, 1, 12, 3, 8. 6, 4, 1, 12, 3, 8. 6, 4, 1, 12, 3, 8. If there is a space, I will mark it. 6, 4, 1, 12, 3, 8. Very simple. What I will do? I will not waste your time. Okay. So total numbers are 1, 2, 3, 4, left to right, 5, 6. Okay, done. Now I will write data. Okay, my data is equal to 6, 4, 1, then 12. I will write 12, then 3, then 8. Done. Okay. Now this is the minimum heap. What I told, minimum, this time minimum. I will never touch this part. This part I will never touch. Done. So after then this person will ask who? This will ask, 1 will ask who is minimum. Okay, 1 is already minimum, no problem. Okay. Now this 4 will ask who is minimum. He is asking to these guys. Okay, this child. Who is minimum? 3. Okay, 3, 4 will come here, 3 will come here. Now lower part done. Okay, now this 6 will ask who is minimum? 1 is minimum. This 6 will come, 1 will come. This is the minimum heap. Done. So this is the minimum heap, and in minimum heap and maximum heap, how to delete? Now one by one you can also delete. That is the sorted method. Okay, already we explained last time how to delete. You can go, and thank you so much. And you should send this information to everyone. Similar type of questions will come in your placement drive as well as in your exam. Thank you so much.